For centuries, the academic library operated as a passive warehouse. Its primary function was the physical storage and protection of printed media. But today, we have entered a completely new era where information is primarily networked rather than physically housed. This has triggered an infrastructure inversion. The library has transitioned from a centralized storage facility into an active, distributed router of scholarly workflows, managing a vast scope of inputs, routing everything from scholarly databases and streaming media servers to raw research datasets. To see how the system actually operates, we will analyze the physical-digital ecosystem through the architecture of Harvard, the Massachusetts Institute of Technology, and North Carolina State University. This socio-technical inversion forms the essential framework for institutions engaging in modern knowledge creation. The first shift in this model is the move from institutional ownership to digital access. Libraries no longer prioritize physical stacks. They manage digital licensing and cloud curation. This requires managing thousands of e-journals, multimedia platforms like Canopy, and the high-resolution digitization of historical archives. Once acquired, the library faces a logistical hurdle, engineering the seamless remote delivery of these assets to researchers regardless of their location. The University of Toronto provides a clear example of how to manage these digital logistics. Their RACER system, or Rapid Access to Collections by Electronic Requesting, demonstrates this workflow. It fetches digital documents and routes them directly to a researcher's device, bypassing the need for physical library transit. In a digital environment, the speed of access logistics dictates the overall research velocity of the university. However, rapid access creates a new problem. Without precise navigation, the sheer volume of available data creates a bottleneck for the researcher. This requires a change in human capital, where the librarian moves from a keeper of books to an active research consultant. The University of Illinois offers a proactive model for this kind of pedagogical support. Their Savvy Researcher workshops train students in advanced Boolean searching to refine queries across specialized databases. They also integrate the use of automated citation management tools like Zotao to help organize large-scale research projects. Finally, they provide instruction on bibliometrics, allowing researchers to track the actual influence of their work through impact metrics. This training provides the critical filter required to separate credible academic research from pure digital noise. This leads back to a spatial paradox. If the primary assets have migrated to the cloud, why does the university still need a physical building? The physical floor plan has been inverted. Space once reserved for books is now dedicated to high-density, interdisciplinary technological collaboration. The James B. Hunt Jr. Library at North Carolina State University is an architectural example of this transition. The facility houses a dedicated visualization lab, a space where researchers physically manipulate complex datasets on massive, immersive digital displays. It also provides makerspace infrastructure, giving students access to rapid prototyping tools like 3D printers and laser cutters. Specialized environments like the Game Lab allow for direct research into immersive media and software design. The library functions as a hardware-rich incubator where research is actively manufactured. As research outputs scale, institutions face a mounting technical hurdle, managing the volume of raw, unstructured data. Global funding agencies now mandate that this raw data be securely preserved and made publicly accessible. Harvard University's library system provides the institutional framework to meet these requirements. Central to this is the FAIR Data Standard, ensuring that research outputs are findable, accessible, interoperable, and reusable. Platforms like the Harvard Dataverse catch raw data files and ensure they are standardized and interoperable for long-term preservation. The library also manages open access repositories like Harvard Dash, hosting faculty research directly to bypass traditional publishing paywalls. By enforcing these technical standards, libraries create the foundational interoperability needed for global scientific collaboration. These systems, the hardware at NCSU, the data governance at Harvard, the logistics of Toronto, and the pedagogy of Illinois, function as a single integrated machine. This infrastructure is designed to serve more than just the currently enrolled university population. Libraries extends this network to the public through open educational resources and partnerships that provide courses to independent global learners. Elite institutions like MIT and Cambridge contribute to this public layer, making high-level research and archives accessible beyond the campus walls. The Digital Age Library derives its value from its ability to engineer the workflows of the future. It has become the infrastructural backbone, ensuring that knowledge remains usable, verifiable, and accessible for lifelong global learning.